Interesting topic here, which is finding the area of two-dimensional shapes or two-dimensional objects. First of all, you look at the question and they're asking here for the area of this shape. You must ask yourself, you must start by asking yourself, what is the 2D shape that I have in this question? If you look at it, we have two parallel sides here, and I have four sides, an object with four sides, four angles, and two of the sides are parallel. So basically, this is a trapezium. We call this when we have a shape that has four sides, four angles, but two of the sides are actually parallel. We know that they're parallel from these two arrows here. So we call this shape a trapezium. So first of all, I must identify what shape do I have in hands. Second thing that you have to ask yourself is, what do I need to actually find the area of a trapezium? We need to know the length of each side of the two parallel sides. As we can see here, 7 and 4. And we need to find as well the vertical distance. The vertical distance. Vertical, it means the distance that creates 90-degree angle with both sides. We need to find the length of the vertical distance between the two parallel sides. So we need two parallel sides, 7 and 4. So we highlighted the two parallel sides, as you can see here, and we underlined them. So we're going to use these two numbers to calculate the area of this trapezium. And we need the vertical distance between the two parallel sides. We have just drawn the vertical distance between the two parallel sides. And we're going to call it D. But it is unknown for us. So we identified the two parallel sides of this trapezium, which are 4 and 7. The vertical distance, we specified the vertical distance between the two parallel sides and we named it as D, and it's unknown. So why D is unknown? Shall I assume that D is equal to 4? No assumption in maths unless there is an information that is given to you in the question to tell you that this length or this side that is 4 centimeter is actually perpendicular on the 7 centimeter side as well as the 4 centimeter side, then we cannot assume that it is. So the answer is no. There is no assumption, like I explained. There is no given fact that the side that is opposite to D, the side that is opposite to D, which is the 4 centimeter, is actually perpendicular on the two parallel sides. Meaning we don't know if this angle here is actually 90 and this angle here is actually 90. There is no given information that is telling us so. D is perpendicular on both parallel sides, while D, we know that it is perpendicular on both parallel sides because we drew the distance, the vertical distance between the two parallel sides. So it means that the angle, this perpendicular side, it creates 90-degree with the first parallel side, which is 7, and the second parallel side, which is the 4. use the right angled triangle. As you can see here, once we drew this line, once we drew this perpendicular height or perpendicular distance between the two parallel sides, we created here this right angled triangle. And as you can see, this is 90, and the line, and the side that is right across the 90-degree angle, the length of it is actually 5 centimeters. Okay, so D is perpendicular on both parallel sides. Use the right angle triangle to find D and name this triangle as ABC. As you can see, ABC, or we can call it CBA. Now we need to find the length of AB. So the hypotenuse is known because 5 centimeter is right across the 90-degree angle. So the 5 centimeter is our hypotenuse. And how did we find BC? If this side, the first parallel side, is 7 and the second parallel side is 4, and I drew this perpendicular from this point, then BC is actually equal to 7 minus 4, because 7 is the total length and 4 is part of the total length. So the remaining part, we're going to subtract the 4 from 7. It's gonna be 3 centimeters. Accordingly, so we have right angle triangle ABC. The hypotenuse is 5 centimeters long and BC is 3 centimeters. So this AB, which is D, the distance between the two parallel sides, is my unknown. Accordingly, how can I find D? We're going to apply the Pythagorean theorem on this right angle triangle, which is ABC, in order to find D. So apply the Pythagorean theorem on right angle triangle ABC. And the Pythagorean theorem hypotenuse to the power of 2 is equal to the vertical side to the power of 2 plus the horizontal side to the power of 2. So this is the vertical side BC, which is 3 centimeters, and the horizontal side AB, which is the D, is actually my unknown, and D is the horizontal side. So the hypotenuse, we substitute now in this rule. So 5 to the power of 2 is equal to the vertical side is 3 to the power of 2 plus D to the power of 2. Now we are going to apply opposite operation. I always like to guide you into doing all your steps before you actually hit to finding the final answer using the calculator. So we all know that 3 to the power of 2 is actually 9, so it is a number. So to get rid of it, since we are solving for D, to get rid of 3 to the power of 2, you're going to subtract. Why? Because the operation here between the unknown, which is D squared, plus 3 to the power of 2, the operation is adding. So we solve for D by applying opposite operation. So we're isolating D. We want D on its own on this side. So we're going to subtract 3 to the power of 2. Whatever I apply on the right side, I must apply on the left side. So D squared is equal to 5 squared minus 3 squared. But we are trying to find D, not D squared. So we must square root each side of the equation, which is as following. And accordingly, D is equal, if we insert all this square root of 5 to the power of 2 minus 3 to the power of 2, if we insert this in the calculator, we're going to end up with D is equal to 4 centimeter. Place whatever you find on your diagram. Now, so that's what we found so far. Again, we have right angle triangle ABC. We found BC, which is 3. We found D here, which is 4, and the 5 centimeter, which is the hypotenuse, is actually given to us. Accordingly, can I now find the area of this trapezium? So the last question that you should ask yourself, can I now find the area of this trapezium? The answer is yes. The length of the two parallel sides is 4 and 7 centimeter. And the vertical distance between the two parallel sides is 4 centimeter. Let's write now. So I underlined on the diagram, every single number that I need to use in the formula of finding the area of a trapezium, so that I know which numbers I have to use. So apply the rule of finding the area of trapezium. What is the rule? Area of a trapezium is equal to 1 over 2 times, in brackets, the sum or the addition of the two parallel sides times the distance between the two parallel sides. So that's how we write it. We say area of a trapezium is equal to 1 over 2 times, in brackets, the sum or the addition of the two parallel sides times the distance or the vertical distance between the two parallel sides. Let's now substitute in this rule. 1 over 2 times, inside the bracket, the two parallel sides are 4 and 7. So 4 plus 7, the sum, the addition of the two parallel sides, the addition of 4 and 7, times the distance between the two parallel sides is 4 times 4. Now this is ready to be inserted in the calculator, and if you do so, you will end up with area is equal to 22 centimeters squared. Remember, the measurement unit of finding the area of any two-dimensional object or any two-dimensional shape is centimeter squared, meter squared, millimeter squared, and so on. This was our lesson for today, and I would like you to try on your own to find the area of this trapezium as well, following the exact same steps that we applied in the previous example. And you must end up with this answer. If you do, then it means that you totally understood how to find the area of a trapezium. If you don't end up with this answer, please watch this video once again and try again to calculate the area of this trapezium. Thank you.